This video is about a clustering algorithm called K-means algorithm, used extensively in computer vision. To fully understand the algorithm, one must be aware of the following concepts: object recognition and classification, unsupervised learning, and what clustering means in the context of computer vision. Object recognition and classification, which are used interchangeably, are defined as finding and identifying objects in images such as biological cells in a tissue, or car on a road. Unsupervised learning, in contrast to supervised one, needs no training data. It is used to describe some hidden structure from unlabeled data. For example, customer segmentation in a clothes market. Since there are no training examples, it is difficult to choose a criterion to evaluate a solution. Clustering can be defined as an action of grouping a set of objects in an image, based on a feature. For instance, similarity in shape or form, color, or the physical position in the image. This is a quick introduction to K-means algorithm. Step 1. Given a set of data points, where each point is one instance. Each instance has n attributes. Choose the number of clusters to be k, and parameter delta, as the critical deviation. Step 2. Randomly initialize the centroids of the k clusters. Label them accordingly. Step 3. For every instance, calculate its Euclidean distance relative to k centroids. Assign the instance to the nearest cluster. Step 4. Find the mean position of each cluster, and choose that position as the new centroid. Step 5. If the deviation of position of the centroids between iterations is small enough, finish the algorithm. Otherwise, jump to step 3. A graphical example of the method. To show how the algorithm works, the following pseudo-random data set has been chosen. K is equal to 2, and delta value is equal to 0. Two centroids, one yellow and one blue, are picked. Next, assign the instances to two clusters by their distance to the centroids. The red line is used as a visual tool for this purpose. Next, find the new mean position of each cluster and choose it as new centroid. Again, assign the instances to two clusters by their distance to the new centroids. And find the new mean positions of each cluster. Choose the new centroids. Repeat this process until the deviation of the last and the new centroids is 0. These are the resulting clusters. No secret that this method can be quite labor-intensive if one uses some more complicated data sets. Application areas for the K-means algorithm are many. Customer market segmentation, analysis of social networks, placement of computer clusters and data centers, analysis of astronomical data, or medicine such as medical histology analysis. Which is the topic for the next couple examples. This image represents the original picture of the human tissue. The rest are the resulting clusters using K-means method, with k equal to 3. This image represents the tissue of the brown trout. K-means method with k equal to 2 gives the resulting clusters. Clear advantages of using K-means method. Its nature of unsupervised learning needs no a priori knowledge. It is simple to implement. It is flexible in regards to adaptation of the k value to the natural structure of the given data. There are also some disadvantages, such as assumption of the uniform cluster size, the number of instances in each cluster is similar, and the variance of the distribution in most cases is spherical. Which is simply not true, in the majority of cases. Lastly, the graphical example with the algorithm shown earlier, has been implemented in MATLAB, and run with the same data set. The resulting clusterings are the same as in the mentioned example. Thank you.